All right, lesson 1-02. This is all about key features of linear functions. Here's what we're going to learn today. We're going to learn to identify key features of linear functions. What are some of those key features? Well, we might call them the x-intercept, the y-intercept. We could use the term zeros, which, by the way, a zero is an x-intercept. Those are the same thing. So go ahead, draw a circle around zeros. Draw a circle around x-intercept. Connect those two. Those are the same thing. And we're also going to learn about slope. So we're going to find the x-intercept, which we could call zeros, the y-intercept, and the slope in mathematical problems. That's what we're going to do today. So our success criteria, what are the three things? If I come by and I'm asking you for questions, these are the questions I might be asking you. Can you identify the x-intercept? Real quick, show me with your arms. Which one's the x-axis? So the x-intercept is going to be where the line crosses this x-axis, okay? I might ask you, what is the y-intercept? Okay, show me which one's the y-axis. It would be where the line crosses that axis. And then we can calculate the slope. Question for you. Does anybody remember slope was equal to a formula? It was something over something else. Do y'all remember what that formula was? Slope equals, give you a hint. Oh, that's the equation for a linear function is slope intercept y equals mx plus b, but there was a saying for slope. It was slope equals something over something else. Starts with an R.
Range over.
You were giving me the formula. It's rise over run. Yes. And I heard you start to say y2. That's correct. If you wanted to break it down into a formula, it would be y2 minus y1 divided by x2 minus x1. All that is true. 8th grade all over again. Yep. Okay, some key terms that you'll hear me say today. I want you to know that a couple of these mean the same thing. Slope on a linear function, the slope and the rate of change means the same thing. These are identical. Okay, on a linear function, that means a line, a slope and the rate of change will be the same thing. You'll hear me say a linear function. That just means it looks like a line. There's another set of words on here that mean the same thing. I've already told you once today. Do you remember what they are? No, those are different. X and Y intercepts are different. There's another set of words up here that mean the same thing. Zero and x-intercept. Very good. These mean the same thing. So these are interchangeable. They mean synonyms. They're the same thing, same meaning, different word. And slope and rate of change are also. Now, guess what? Initial value, it has the same meaning as something else. The initial value is the same thing as the y-intercept. So all of those pairs have words that are interchangeable. Do y'all remember? We talked about it last class. What's the definition of a function? Each x value has exactly one y value. That's right, exactly one y value. Great. All right, I'll let you get that copied down. All right, so let's take a look at some of this math. I have right here a definition chart for you. All right, so here I have, if you will, like a cheat sheet for some of those words. So I didn't write down the definitions on the previous page for some of these because I knew they were coming right here. So slope, what I told you, this synonym that means another name, same meaning, is rate of change. Let's see if you caught this. The ratio of the change in the y coordinates, which is a blank, to the change in the x coordinates blank. Okay, I said this as something over something else. What did I say the formula was? Rise over run. Those are your blanks. Let's fill those in. It's rise is your first blank. Rise over run. All right, our next words, x-intercept or zero. The definition for those, it's the point where a line crosses the x-axis of a graph. One more time, show me with your arm. Which one's the x-axis? Ivan, which one's the x-axis? This one or this one? Yeah, you're right. This one. It's this way. That's the x-axis. All right. It's going to always be in the form like this. You're going to write it as parentheses x, comma, 0. The x-intercept will always be written in that form. That means the y value is 0. The x can be any number, but the y value is always 0. Okay? The y value is always 0 in the x-intercept. Now, let's talk about the y-intercept. Okay, everybody show me the y-axis. Which one's the y-axis look like with your arm? Up and down like this. Ivan, show it to me. Which one's the y-axis? Yeah, there you go, Valerie. Good, thank you. The y-intercept, also known as the initial value, it's the point where the line crosses the y-axis. It's always in the form. What do y'all think the x value is on the y-axis? 0, good. So it'll be 0, comma, y. That's how it'll look. So now we have our definitions for today. All right, so let's take a look. Here I have what's called a linear function. I want you to look at this black diagonal thing here. Why do you think they call it a linear function? Linear. Why do you think they call it linear? Because it's a straight line. That's right. Now, some things I want to point out here is this point here is called the y-intercept because that's where it crosses the y-axis. So what would be the coordinates of this point right here? What would be the coordinates? The x value and the y value is what I'm asking. What would be the coordinates for that point right there? Okay, I hear 0, 2, and I hear 2, 0. Let's talk about which one do we write first, the x or the y value? X. So here's my x-axis here. Let me change this to blue. Let me change it here, blue. Okay, here's my x-axis. If you took this point to the x-axis, where would this hit the x-axis? 0. So the x value is 0. What's the y value there? 2. So the correct way of writing the y-intercept would be 0, comma, 2. Everybody okay with that? Now in red, we have what's called the x-intercept because that's where it's crossing the x-axis. Okay, I'm going to ask this question again. What do we write down first, the x value or the y value? The x. So what is the x value right here? 3. Good. Now what is the y value if you took it to the y-axis? 0. Perfect. So the point should look like 3, comma, 0. Okay, I have some extra practice. We'll do those points now. This extra practice here, I've just picked 2 points at random, this x1, y1. I just picked them at random. I just wanted to practice a couple extra times. What would be the coordinate for this point right here? What's the x value? 6 is good. 6 is it. So put 6 in that spot right there. That is the x value. Now, what would be the y value? -2. Okay, okay, okay. Now this time, I'm going to do a countdown. So don't yell it out right away. I want everybody to have a chance to take a look. Sorry, I keep writing ugly 2s. Let me try this again. There we go. That's a better 2. 6, comma, -2. Okay, now let's come up here and let's identify this point there. I don't know if I have that color. So this one here, I'm going to do a countdown. Don't yell it out yet. To find the x value of this point, you're looking for the x value of this point right there. So where would this be in line with the x-axis? 5, 4, 3, 2, 1. -3 is the x value. -3 is the x value. Go ahead and put that in. That is the x value. You take it to the x-axis first. Okay, now the y value. 5, 4, 3, 2, 1. Okay, I'm hearing a lot of the girls participate, but I'm not hearing very many boys participate. I need y'all all speaking up, please. Okay, so let's try that again. What's the y value? 5, 4, 3, 2, 1. That's better. That's better. Okay, so now let's go do some, find the slope, the 0, and the initial value. These were some synonyms we had. So slope, as we've talked about, is rise divided by run or rise over run, however you want to read that. Let's talk about the rise. This line, what you do is you pick any 2 points. Are y'all okay if I look at the blue point and the red point? Okay, let's look at the blue point and the red point. Going from left to right, meaning from the blue to the red, does my graph go up or does it go down as you go left to right? It goes down. Now, how many units does it go down to get from this blue point to the red point? How many values straight down? How many does it go down? Nope. Nope. Two. 1, 2. We go 2 blocks down. So over here on the rise, I want you to put -2. I go down 2 units right there. Now, how many units is my run? That means straight to the side. So I went down 2 units. Now, how many do I go to the side? 3. Perfect. I'm going to put that in red. So if I asked you what the slope is, you'd tell me the slope is -2 over 3. -2 over 3. That's how you would say that. What is the slope? -2 over 3. Very good. Okay, the 0. Now here we go. Vocabulary. Oh man, Mr. Voorhees, we turned the page. I don't remember. Okay, let's think about what's 0 mean? X-intercept. So what value does this line cross the x-axis? That's my question. What value does this line cross the x-axis? 5, 4, 3, 2, 1. Take a guess. 3. Ariana is correct. 3. 3. Did I say it right? Yeah, 3. The value is 3. When it just says 0, you only give the x value. It's an x value of 3. The 0 is 3. Do y'all remember what initial value meant? The y-intercept. Okay, I'm going to tell you, you're going to write it similar to this. So I want you to think about what you guess the correct answer should be here. I'm going to do a countdown and call it out. You're not hurt if you're wrong, but I just would like to know what you would think. What value are you going to guess for initial value? 5, 4, 3, 2, 1. 2. I heard Kiko first. He's correct. It is 2. Why is it 2? Because this line crosses the y-axis at the y value of 2. So as an equation, come down here. There's this line equation. You usually write it in the form you might remember from 8th grade. Y equals mx plus b, where the m represents the slope. Why they use the letter m, I don't know. And b represents the y-intercept. So if we were going to write our equation, it would look like this. Y equals, what did you say the slope was? Let me slide up just a little bit. What's our slope? -2 over 3 x plus the y-intercept value, the initial value. What's our initial value? 2. That's how you could write an equation. Now, some of you remember that really well from 8th grade, right? So it's only fair, if I'm going to review you something on 8th grade, I might as well also show you something from the future. Let's fast forward to your senior year in high school, and you come back to me for AP Calculus. We would write this equation as another way. Is anybody intrigued to know how you might write this when you're a senior? You're not intrigued at all. Well, I want to show you. When you're a senior, you would actually write this equation. I'm just going to write it, and I'm going to see if you can figure out the pattern here. You would write this equation as 2x plus 3y equals 6. Now, the 6, you'd have no idea where it came from, but the 2 and the 3 you can find. What do you think the 2 and the 3 come from?
Slope.
Good guess. The slope, they do have the values 2 and 3, except the slope is -2. So it's not exactly the slope that I got that from. The x-intercept and the y-intercept, but here's what's tricky, is the x-intercept is actually at 3, but when they write this equation, you pair the letter X with the Y value, and then you pair the letter Y with the X value. Now, how did I get the 6? You multiply the two numbers. What is 2 times 3? 6. And so that would be how you might write an AP Pre-Calc. But we're not in AP Pre-Calc. If you don't want to know that, you don't have to know that. But today I'm just going to write it down just because if I'm going to review you on 8th grade, I might as well also teach you the future, right? Isn't that only fair? If I want to teach you backwards, I might as well teach you forwards too. So with that, some of you are like, no. Let's move on. So I'm going to go ahead and just put this down here. How about this? If I say this is AP Pre-Calculus, that means like your senior level stuff. You don't have to know this now, but I can't even spell, sorry. Calculus, there you go. That's just extra, but that's how you would write that equation in the future. All right, I'm going to continue on. You ready? Ready or not? Here we go. Let's look at another one. Example 1 here. So the last one was exemplar. I wrote out everything where you could see it nice and easy. Now let's ask some questions. Today's about identifying key features. So what that means is, honestly, I should just be asking you about features rather than writing everything down. So if I said, what is the 0? What do I mean by the 0? Edgar, what do you think? When I say, what is the 0? What do you think I mean? Look back in your packet, first slide. It was on there. If you, 0's on the first slide. I think it was, is it the 3rd slide or the 4th slide on the first page? A 0 is the same thing as a x-intercept. So what is our x-intercept on this problem? That's right, it's 2. Let me write it this way. The 0, I'm going to write my z like this so it doesn't look like a 2. The 0 equals 2. I'm going to go ahead and put this dot in on red so you can see it. That is the x-intercept, which we also know as the 0. Until we get our vocabulary done, let's go ahead and write that out as well right here. Go ahead and just put an arrow at it and say that is the 0. So if you look back in your notes, okay? All right, it says, what is the slope? All right, Julia, your turn. What is the formula for slope? Do you remember? Rise over run. Very good. The rise divided by the run. So here's how we do that. We have to find 2 good points. Now, what do I mean by 2 good points? Points that hit at integer values like this. So this is a good point. The x-intercept is a good point. But let me ask you this. Would this be a good point right there? Does that hit at integer values, meaning whole numbers? No, that's not a good point. Would this one be a good point? No. Would this one be a good point? Is that a good point? Does it look like the x value is a whole number and the y value is a whole number? Yes, that's a good point because the x is a whole number and the y is a whole number. So let's find the rise. How much do I rise going from the red to the blue? How many units do I go up from the red to get to the blue? How many straight up do I travel? How many boxes? 3. Perfect. I go up 3. My rise is 3. Now let's talk about my run. How many, from this spot, how many boxes over do I go to get to the blue? 1. So it's 3 divided by 1. Now that can reduce. What is 3 divided by 1? 3. You could just rewrite that as the number.
All right, thank you, Russian teachers and students again.
All right, now that we found the slope and the 0, let's slide down to the bottom and ask for the equation. Now, once again, the equation of a line in slope-intercept is y equals mx plus b. Now, I've told you before, but you tell me this time, what does the letter m represent in this formula? The slope. We know what the slope is. What's our slope? It's right here. 3. Do we know the y-intercept? We haven't found it yet, but you can look over. Here's someone saying -6. I agree. It is -6. That is the y-intercept. Let's go ahead and label that on the graph. That's the y-intercept. So the 8th grade way of writing this equation is to say the equation is y equals, what's our slope one more time? 3x plus, actually this would not be plus. What I would do instead is I would say minus 6. That's my 8th grade way of writing this equation. Do you want to just leave it as 8th grade way, or you also want to go to the future? No one wants to go to the future? Just leave it 8th grade? Okay, we'll leave it there. That's your equation right there, okay? Now we've done an exemplar, we've done an example. Let's try a second example before I move on with you starting to try any. Let's try a second line, or a second example here. It says the graph of a linear function is shown on the grid. What are the x-intercept and y-intercept of the line? Okay, this time, I'm going to give you a second. I want you to put points on the graph and label the x-intercept and the y-intercept. I'm going to give you a few seconds to do this on your own. All right, so let's talk about the x-intercept and the y-intercept. With your arm, show me which one, which axis is the x-axis? Show me with your arm. Which one is the x-axis? Ivan, which one you got? Gustavo, which one you got? Pico. Which one's the x-axis? Is it this one or this one? That's the y. It is this one, yeah. So let's go to the x-axis here. Where does the line cross this x-axis? What value do you see that the line crosses this x-axis? -2, perfect. So this is right here, the x-intercept. I'm going to go ahead and label it over here. If you want, you can just do x-int like that. X-intercept, that's what that stands for. Now, here's a technical thing. When you write the x-intercept, if you write it as x-intercept, mathematicians usually write it as a ordered pair, meaning they would write it in the form with an x comma y value. So if I wrote it as an ordered pair, what's the x value? What is the x value on this x-intercept? -2. What is the y value? 0. Very good. It's 0. It doesn't show you a 0 there, but that's what it is. This would be a 0 right in there. Very good. So it is a 0. However, here's what's tricky. If they use the name 0, if they're using the name 0, what mathematicians know is that name is telling you your y is 0. If they wrote the name 0, then you don't have to write it as an ordered pair, and you could say the 0 equals -2. That's the difference. It's kind of tricky. But we'll work on that as we go. So if you write it as an x-intercept, you would expect the answer as an ordered pair. That means an x and a y. But if they use the name 0, since the 0 is talking about the y, you only have to put the x value. Does that make sense? Okay, now it's similar with the y-intercept. So y-intercept, here's, if I wrote down y-int like that, we would have to get the x and the y value. So let's go over, tell me one more time with your arm, which one's the y-axis? Everybody's arm should be going up and down. Gustavo, Ivan, make sure you show it to me. Up and down like this. Y-axis, there we go. Where does the line cross the y-axis? -8? +8?
Oh,
It's okay. +8. There we go. +8. That is my y-intercept. Which I'm going to just write as y-int, but that stands for y-intercept. So if you were writing the y-intercept, you would expect it to give you the x and the y value. So on the y-intercept, here's my first question. What's the x value? If you followed it to the x-axis, what's the x value? 0. Good. What's the y value of the y-intercept? 8. Perfect. Now, the synonym for y-intercept is the initial value. If they said, what is the initial value? That's when you can say it's just 8. Like that. All right, with that, it's time to write our equation. I have way too much space. It's way down there. Remember, the equation comes in the form y equals mx plus b. Y equals mx plus b. What does the M stand for? Slope. Do we know the slope yet? Okay, let's find our slope. Let's look between the red and the blue point. How many units up does this graph rise going? I'm going left to right. I always choose the left point, then the right point. How many points, how many boxes, how many units does this graph rise going from this red to the blue? 8. Very good. My rise is 8. My slope is the rise over run. Rise over the run. My rise is 8. Very good. Now let's see. What is our run this time? How many boxes? How many units do I run from the left to the right to get from the red to the blue? 2. So it'd be 8 divided by 2. Can that reduce? Kiko's telling me it does. He's correct with his value as well. What do y'all think? Yeah, what is 8 divided by 2? 4. So that would be my rise. So my equation would look like this. Let me scroll way down here. It would be y equals 4x. What's the b stand for again? The y-intercept or the initial value, which we said is 8. There's your equation right there. That's where I would go for that. The initial value is the b, or the y-intercept. Okay? With that, it's time for you to try your own problem all by yourself. So I have your first DOL here. Here's the instructions. This is just for me. Really, it is kind of for you to help you go in steps. But first, what I want you to do is come up here and identify what you're looking for. Label each one on the graph. So each graph, I want you to label what the 0 is and the y-intercept on each graph. And then match which one would be the correct answer, okay? So DOL number 1, let me pick this, show this so you can see the whole problem. DOL number 1, go ahead. All right, now everybody, now that we've done this one, everybody turn your packet over. And you have a second DOL. We're going to try this one more time. I've just now changed the features. So I'm going to ask you, so turn your page over. And it'll be the first slide on the next page. It says here a linear function t has an x-intercept of -1 and a y-intercept of 5. So just to make sure everybody's on the same track, x-intercept, which one's the x-axis again? What? Show me with your arms. I'm getting most across the room. Missing Ivan, Kiko now. There you go. All right, that's the x-intercept. So I want you to find your x-intercept of -1 and y-intercept of 5. Ready? Go. All right, now let's move on here. So as a kind of review of what we've done, when we go to calculate slope, now when I say slope, I could also say rate of change. They mean the same thing. Now, we did this on the previous slides. We need to identify a certain number of good points. Do you remember how many good points we need to find? 2. You need to have 2 good points when you find slope. We need to find 2 good points. Now, we can label these points as x1, y1 and x2, y2. So we need 2 good points, and that's how we will label them. We will substitute into the values into the slope formula, which today we've been calling it rise over run. You could also see it written as y2 minus y1 over x2 minus x1. That's the same thing as rise over run. If you don't want to use the formula, you can use rise over run. It's the same thing, okay? I don't have that much room, so I'm just going to write it about. That's the rise, that's the run. The last step, there's a math word here. To calculate the slope, we have to simplify. Now, what does that mean? Do you remember earlier we had that problem where the rise was 8 and the run was 2? Do you remember that problem where we had rise was 8 and run was 2? And I asked you, can we simplify 8 divided by 2? And you told me the answer was 4. That's what this step means. It means as if you can divide it, go ahead and divide it to give it a more simple number. That's all that means, okay? So that's a review for slope or rate of change. Let's look at our examples for these. I'm going to speed up a little bit because We've already kind of practiced this on a few of the previous slides. Okay, so example 3 here. Example 3 says the graph of this line is shown. The coordinates of both points indicated in the graphs are integers. And we want to know what is the rate of change of y with respect to for x. Now, what does rate of change mean? Does anybody remember the synonym for rate of change? Synonym means different word but same meaning. Look back on the previous slide. Slope, that's it. The slope. I want to know what's the slope. So remember, we can do rise over run, or you can use your formula. It's the same thing, okay? So on this one, let's use this point right here. This is our x1, y1. How about that? This point right here, that's going to be our x1, y1 right there, this point. This point down here, we'll say is our x2, y2 point. Now to help us out, what are the coordinates for this point? What's the x value? If you took this to the x-axis, what would you get? -3, good. That's the x value, and I heard you call out the y value is 5. Okay, now let's take a look at this one's value. What's the x value here? If you took it to the x-axis, 9. And what's the y value? -5. Okay, now we could use the formula. I'm going to write the formula, but I want to show you how counting using triangles are the easier way. You could do the formula. You could do y2, which is -5, minus y1. Y1 is 5, divided by x2. X2 is 9, minus x1, which is -3. Now, I think it's harder to use the formula. Now, you could do the math that way. I think that's harder. Do you want me to show you what I think is the easier way? The easier way is doing this. How many boxes do I need to move down if I'm going to make a triangle here? I'm going to do the rise first, so I'm going down. How many units down, how many boxes down do I move to get to that value there? So let's count the boxes together. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So come over here and say this is the same thing as -10. Mathematically, -5 minus 5 more is -10. If you remember our number line, you go left 5, you would go left 5 more. So we're at -10. Now let's do the run. We're starting here. Count the boxes as we go across. Let's count these together. Let me draw it first so you can see the triangle. Okay, starting here. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The reason that becomes a 12 is 2 negatives become a positive. It's 9 plus 3, which is 12. Okay, can I simplify that? Does this reduce? It does. The number 2 goes into both numbers. Do you know how many times 2 goes into 10? 5. So it'd be -5 over. How many times does 2 go into 12? 6. That's our slope. Now, for the sake of time, I'm going to write out the equation real fast. Remember, our formula is y equals mx plus b. The slope you just found is -5 divided by 6. X. And then the y-intercept. I see it's a positive number. What do you guess that y-intercept is right there? Where do you think we cross the y-axis? It's in the middle of 2 and 3. What number's in the middle of 2 and 3? 2.5. Ivan, you got it. 2.5. That's it. So that would be our equation this time. Carla. Okay, let's Try another one. Example 4. Do y'all want to do the formula or do you want to do the triangle technique for slope? What do y'all want to do this time? The formula or the triangle technique? Triangle technique? Let's do the triangle technique. So do you see the points? Let's go ahead and label these. So this is our first point. The reason it's the first point is it's because it's on the left. The one on the left is the first point. Your point on the right is going to be our second point. So first point looks like x1, comma y1. Second point looks like x2, comma y2. Same instructions. We're looking for the rate of change. What does rate of change mean? Slope. So what I'm going to do is I'm going to draw a picture and I'm going to do the rise first. Remember how slope is rise over run? Rise means either up or down in math. Rise means either up or down. We're going to do the rise first and then we'll do the run. So on my triangle, from the blue point to the red point, I go down first. I don't go left or right. I go up or down first. So this problem, I go down first and then I go over. That's how you would draw your triangle. We would do the rise first, which means it goes down, and then we would do our run second, which will go to the right. Does that make sense to everybody how I'm doing this? Let's count boxes. So starting here, you count once you complete a box. So we go 1, 2, 3, 4, 5, and 6. I go down 6. Over. Let's see our run. 1, 2, 3, 4, 5, 6, 7, and 8. It's 8 over. Can that be reduced, or is that how it stays? It can be reduced. What number goes into both 6 and 8? 2 does. How many times can 2 go into negative 6? It's obviously a negative number, so maybe I could just say, how many times does 2 go into 6? 3. Since it's negative 6, it's going to be negative 3. How many times can 2 go into 8? 4. So that's my slope. If we were going to write the equation, y equals mx plus b, you would say y equals, what does m stand for again? Slope, negative 3 over 4 x plus, what's our y-intercept in this problem? It's not labeled. 4, very good. That's our y-intercept. So it'd be plus 4. All right, with that, do you have any questions over this? We now come to example 5, where this time they don't actually show us the picture. So let's plot these points and see what we can come up with. It says a line contains the points negative 2, comma, negative 2, and 4, comma, 2. Question will be, what is the slope? So let's go plot these points. Negative 2, negative 2. This is our first point, so I'm going to call this x1, comma, y1, because this is the first point they showed me. So negative 2, which way do I go? Up, down, left, or right? Left 2, and then down 2. Put a dot there. That's our first point. That's negative 2, comma, negative 2. Okay, our second point. What about 4, 2? You're correct. It will go right 4. We go right 4, then up 2. Right 4, up 2. That's that point. Now you can use your ID badge to make a line. You haven't gotten your ID badge yet? Okay, well, I've got a tool here, so I'll just draw my line like that. Well, Mind freezing up on me? Okay, so we have to find the slope. How do we find slope again? Rise over run. So which one do we do first, the rise or the run? The rise. We're going to do the rise first. So y'all asked for triangle method last time. I'm going to do triangle again here. So rise means either up or down. This one, does it go up or does it go down? Starting from left to the right. Up. So I'm going to draw my triangle going up. Meaning you always draw your triangle going up or down before you go left or right. So I go up to that value, and then I go over this way to this value. Okay, let's talk about our rise. How many units do I move up? Y'all ready to count? Am I going too fast? Are we good? Okay, how many do we go up? 1, 2, 3, 4. We go 4 units up. What's our run? 1, 2, 3, 4, 5, and 6. It'll be 4 over 6. Question, can that be simplified? Yes, 2 goes into both numbers. How many times does 2 go into 4? How many times does 2 go into 6? 3, so it's 2/3. That's our slope. That is our slope. So for the equation, it would be y equals 2/3 x plus, now this is a weird one right here. That is negative 2/3. That y-intercept, that's a very weird value. I don't want to take too much time here. That's negative 2/3. That's where that is. I don't want to spend too much time on that because that wasn't a part of the original problem, but that's where that location is. I know that's not a very pretty number there. That's what that value would be. All right, with that, we have done our examples. And this brings us to our third DOL. DOL number 3 here, what is the slope of the line? And now your last one, try DOL number 4. We want to graph this line.